Hello everybody. Today I can determine if something is expected or fair by seeing if it falls inside the confidence interval. In this lesson, the worksheet is entitled Sample Distributions. It's kind of a follow-up to the previous lesson that we did. So I want to just recap everything we talked about in the previous lesson to make sure we understand all those important concepts. So, what did we talk about in the last lesson? As sample size increases, the mean relatively stays the same, and the standard deviation decreases. We said that the value is expected if it falls inside the confidence interval. And along the same lines as those, something is fair. For example, coin, if the theoretical probability, so for a coin that being 0.5, is inside the confidence interval. That's the main things that we talked about in the last lesson. And let's just make sure we know how to find confidence interval. Confidence interval, which is the range of expected values. It's the middle 95% of the data, is the mean plus and minus 2 times the standard deviation. And we always write it as smaller to bigger. So that's what we talked about in the last lesson, and we're going to be utilizing a lot of this stuff today. So let's start with number 1. In 2013, 1.6 million students took the critical reading portion of the SAT exam. The mean score, the modal score, and the standard deviation were calculated to be, so the mean was 496, the mode was 430, and the standard deviation was 115, which interval reflects 95%. Interval 95%. It's asking for the confidence interval. Now, it's not, if you look at the way the choices are, it doesn't want the actual interval, it just wants you to set it up. So it's the mean plus and minus 2 times the standard deviation. The mode doesn't matter, it's not part of this. So 2 times 115 is just 230. And that's it. That's what it's asking for, this particular question. Normally, to find the actual confidence interval, I would add and subtract those values, but this is a multiple choice question now it's on the regions, and that's all they want you to do. Elizabeth waited for 6 minutes at the drive-thru at her favorite fast food restaurant, and the last time she visited, she was very upset about having to wait that long and notified the manager. The manager assured her that her experience was very unusual and it would not happen again. A study of customers commissioned by this restaurant found an approximately normal distribution of results. The mean wait time was 226 seconds. And the standard deviation was 38 seconds. Given these data and using a 95% level of confidence, was her time unusual? To determine if her time was unusual, I need to see if her time is inside the confidence interval or not. So I have to start by finding the confidence interval, which is the mean plus and minus 2 times the standard deviation. The mean is 226, so it's 226 plus 2 times 38. And it is 226 minus 2 times 38. So I can put those into my calculator. It'd be good if I had my calculator on me. I don't, but I have this one, so it's all good. 226 plus 2 times 38. And then I can copy and paste and do the minus of that. I think it's 150. I've done this question so many times. 150. So I've got 302, I've got 150, so my confidence interval is between 150 and 302, and with any interval, we always go smallest to biggest. So was her time unusual? Well, her time was 6 minutes. So little twist, 6 minutes is 360 seconds. You'd have to multiply it by 60. So is 360 seconds inside the confidence interval? No. So was her time unusual? Yes. It's not an expected value because 360 is not in the confidence interval, the 95% confidence interval. So to determine if something is usual or unusual or expected or not expected or fair, I need to start by finding the confidence interval using the confidence interval formula, mean plus and minus 2 times the standard deviation, and then I see if that value is inside the confidence interval or not. I want you to try number 3 on your own. It's really the same type of thing as number 2. So please pause, try number 3 on your own, and then unpause. Okay. Let's just skip to it. Jessica wants to know if something was unusual. So to determine if something is usual or unusual, I find the confidence interval, which is the mean, plus and minus 2 times the standard deviation. The mean was 11.2. The standard deviation was 3. So it's going to be 11.2 plus 2 times 3, 11.2 minus 2 times 3. That's, again, you can use the calculator if you need to. That's 5.2 to 17.2. Was Jessica correct that 20 math problems was unusual? Does 20 fall inside the confidence interval? It does not. So, yes, it was unusual because 20 is not in the confidence interval. Avoid saying the word it. Don't say it is in the confidence interval. It is not in the confidence interval. That can be very vague. So do your best to not say it, say the actual value that you're looking at. All right. A student wanted to decide whether or not a particular coin was fair. She flipped the coin 20 times, calculated the proportion of heads, and repeated this process for a total of 40 times. Below is the sampling distribution of sample proportions of heads. The mean and standard deviation of the sampling distribution are 0.379 and 0.091. Was it a fair coin? Well, to determine if it's a fair coin, I need to see if the theoretical probability, 0.5, is in the confidence interval or not. So that's what I have to do. To determine if it's a fair coin, I need to answer the question, is 0.5 in the confidence interval? So let's find the confidence interval. It's the mean plus and minus 2 times the standard deviation. It says that the mean is 0.379 plus 2 times 0.091 and 0.379 minus 2 times 0.091. So I go to my calculator, I do 0.379 plus 2 times 0.091. So that's going to be 0.197 to 0.561. So if the theoretical probability is an expected value, then it's a fair coin. If 0.5 is in the confidence interval, then it's a fair coin. Is 0.5 an expected value? Is 0.5 in between 0.197 and 0.561? Yes, because 0.5 is in the confidence interval. 0.5 is an expected value, therefore the coin is fair. So to determine if something is fair, you need to see if the theoretical probability of it is inside the confidence interval or not. Hassan flipped a coin 100 times. It got a proportion of 0.38 heads. He believed his coin was unfair, so he repeated the process 200 times and created a sample distribution. The mean was 0.41. The standard deviation was 0.03. Is Hassan correct? I want you to try this one on your own. So please pause. Try number 5 on your own. Use number 4 as a model. It wants to know if the coin is fair or not. So we need to see if the theoretical probability falls in the confidence interval. So try number 5 on your own and then unpause. Okay. So again, let's talk about what you need to know to start this question. If I want to know if the coin is fair or unfair, I need to see if 0.5, the theoretical probability, falls inside the confidence interval. So the confidence interval is the mean plus and minus 2 times the standard deviation. The confidence interval is 0.41 plus 2 times 0.03 and 0.41 minus 2 times 0.03. You can use your calculator if you need to. I don't need to. That is 0.47 and that is 0.35. So the confidence interval is 0.35 to 0.47. So when I flip that coin, it's expected that it's going to land on heads between 35% and 47%. Is 0.5 in the confidence interval? No. So is the coin unfair? Yes, the coin is unfair. Because 0.5, the theoretical probability of getting a heads, is not in the confidence interval. It's not an expected value. To determine if a coin is fair, 0.5 would have to be inside the confidence interval. We found the confidence interval. It's not, so that is not a fair coin. Now this one's phrased a little bit differently. So I just want to put that out there, and we'll kind of go through it together. But the way it's phrased is a little different. Anne has a coin. She does not know if it is a fair coin. She flipped the coin 100 times and obtained 73 heads and 27 tails. So she got 73 out of 100. She got a proportion of 0.73. She ran a computer simulation of 200 samples of 100 fair coin flips. So this is not her coin. This is a fair coin. The output of heads is shown below. Given the results of her coin flips and her computer simulation, which statement is most accurate? Well, let's see what the range of expected values are for a fair coin. So I'm going to find the confidence interval of the fair coin using this information. So confidence interval is the mean plus and minus 2 times the standard deviation. 0.497 plus 2 times 0.05. 0.497 minus 2 times 0.05. That's 0.597, 0.397. So for a fair coin, again, this is not her coin, for a fair coin, the range of expected values is between 0.397 and 0.597. Her coin gave 0.73. Is her coin an expected value for a fair coin? No. Therefore, Anne's coin is unfair because she got a value that is not expected for a fair coin. If you flip a fair coin, you should get a proportion of heads for that sample size between 0.397 and 0.597. She got something outside of that, so her coin is not fair. Let's just go through the other choices and just look at them. 73 of the computer's next 100 coin flips will be heads. No. Okay, not just because I got 73 out of 100 doesn't mean if I do the simulation again, I'm going to get 73 again. It just means that that's what I got my first one. 50 of her next 100 coin flips will be heads. Theoretically, 50 of them will be, but in reality, it's unlikely that it's going to be exactly 50. It's going to probably be very close to 50. It's likely to be close to 50, but I don't know for a fact that, 50 out of the next 100 will definitely come up heads. Her coin is not fair, again, because her proportion is not an expected value because it does not fall in the confidence interval. 7. I want you to try 7 and 8 on your own. So please pause, try 7 and 8 on your own, and then unpause. Okay, 7. A game spinner is divided into 6 equally sized regions as shown in the diagram below. For Miles to win, the spinner must land on the number 6. Alright, so if it lands on 6, this kid wins. After spinning the spinner 10 times and losing all 10 times, Miles complained that the spinner is unfair. Sore loser, Miles. At home, his dad ran 100 simulations of spinning the spinner 10 times, assuming the probability of winning each spin is 1 over 6. And that should make sense that the theoretical probability of landing on a 6 is 1 out of 6 because there's 1 6 out of 6 possibilities. The output of the simulation is shown in the diagram below. So, I see that all the choices are talking about fair and unfair. So to determine if something is fair or unfair, I have to see if the theoretical probability falls inside the confidence interval. So my first step is going to be to find the confidence interval, which is the mean plus and minus 2 times the standard deviation. 0.157 plus 2 times 0.109, 0.157 minus 2 times 0.109. Anyway, I leave myself a lot of space there. So 0.157 plus 2 times 0.109, and then the minus. So I got negative 0.061 to 0.375. So let's talk about what we just found. Is this the confidence interval for Miles' spinner or a fair spinner? It says, assuming the probability of winning each spin is 1 over 6. So basically, this is saying for a fair spinner, this is my range of expected values of getting a 6. Miles got 0 out of 10, which is 0. So, according to the confidence interval, is 0 an expected value? Is 0 between negative 0.061 and 375? Yes! 0 is an expected value because 0 is in the confidence interval. Therefore, the spinner is fair. The output that he got, 0, is an expected value because it's inside the confidence interval. So let's take a closer look at the choices. The spinner is fair. So it's not choice 1, it's not choice 2. So choices 3 and 4 both say it's not unfair. So let's see which one makes sense. So choice 3, the spinner was likely not unfair since the number 6 failed to occur in about 20% of the simulations. The spinner was likely not unfair since in the output, the player wins once or twice in the majority of the simulations. So, the way this is worded is a little confusing. The confidence interval is the middle 95%. So, if it happens less than 5%, then it's outside the confidence interval. If it happens more than 5%, then it's inside the confidence interval. So 0 occurred 20 times out of 100, which is 0.2 or 20%. Because that's more than 5%, it's inside the confidence interval. So choice 3 is your answer. Choice 4 is saying since he wins once or twice in the majority of the simulations, it doesn't really make much sense, that explanation for this particular problem. 3 does. If it happens more than 5% of the time, then it's inside the confidence interval. If it happens less than 5% of the time, then it's outside. I asked you to try number 8 on your own. Robin flips a coin 100 times. It lands heads up 43 times, and she wonders if the coin is unfair. She runs a computer simulation of 750 samples of 100 fair coin flips. So this is a fair coin thing. This isn't her coin, this is a fair coin. She got 43 out of 100, which is 0.43. So to determine if it's fair or not, we find the confidence interval, which is the mean, plus and minus 2 times the standard deviation. The mean is 0.499. Point 0.049, 0.049, 0.499 plus 2 times 0.049. And minus. So 0.401 and 0.597. She got 0.43. Is 0.43 in the confidence interval? Yes, it's an expected value for a fair coin. So that leads us to believe that her coin is fair, again, because her output is an expected value of a fair coin. So no, it is not unfair because 0.43 is in the confidence interval. Some of you right now are being like, Mr. Schlansky, isn't this like supposed to be math? Like, aren't we supposed to be dealing with like variables and all that good stuff? Well, statistics is quite a bit different. It's much more conceptual. I think it's a lot easier in a lot of ways. It's just understanding the concepts. Why don't you try, I know we're pretty much done with this, we've pretty much gone through the whole thing together, but this stuff could be a little tricky. So why don't you try 9, 10, and 11, try and finish it up right now. So pause, finish it up, try 9, 10, and 11, and then unpause, and I will go over the rest. Okay, now that you tried 9, 10, and 11 on your own, the results of simulating tossing a coin 10 times, recording the number of heads, and repeating this 50 times are shown in the graph below. Based on the results of the simulation, which statement is false? 5 heads occurred most often, which is consistent with the theoretical probability. So the theoretical probability is 1/2, which is 5 out of 10. So that is true. Theoretically, 5 out of 10 should come up the most. And it did come up the most because it has the highest frequency. So that one is true. 8 heads is unusual as it falls outside the middle 95%. So there's no mean and standard deviation here to calculate the confidence interval. But here's what we would do. 8 would fall here. So we're going to look at 8 and then everything more extreme, everything past it. There are 6 of these simulations where they were more than 8. 6 out of 50. 6 out of 50 is 0.12. So that means it occurred 12% of the time. If it occurred 12% of the time, since that's more than 5%, it is inside the middle 95%. This one is not true. 8 heads or more occurred, because if 8 is unusual, then 9's got to be unusual. That's why we include 9 as well. 12% was 8 or more. So that's more than 5%, so it's inside the confidence interval. It's in the middle 95%, so 8 heads would be usual or expected. Obtaining 3 heads or fewer occurred 28% of the time. Well, 3 heads or fewer is, how many dots we got? 1, 2, looks like 10, 11, 12, 13, 14 out of 50, which is 0.28. So yes, that one's correct. 7 heads is not unusual as it falls within the middle 95%. Well, if 8 is in the confidence interval, then 7 definitely will be. But I can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 50 is 0.18. That is more than 5%. That one works. That one doesn't. A public opinion poll was conducted on behalf of Mayor Ortega's re-election campaign shortly before the election. 264 out of 550 likely voters said they would vote for him. So let's see what that is. 264 out of 550. $264 out of 550 is 0.48. So 48% of the people that were asked said they would vote for him. The rest said they would vote for his opponent. Which statement is the least appropriate to make according to the results of the poll? There is a 48% chance that Mayor Ortega will win the election. I cannot say that definitively. All I know is that 48% of the people that were asked said they would vote for him. So I don't really like this so far. Choice 2, the point estimate. So the estimate of voters who will vote for Mayor Ortega is 48%. Yes, that's what this says. This says that out of the people that were asked, 48% of them said they would vote for Mayor Ortega. So I can conclude that approximately my estimate of voters that would vote for him would be 48%. It is most likely that between 44% and 52% will vote for Mayor Ortega. So you can kind of see that's kind of the confidence interval there. It's a little bit more and a little bit less. That sounds pretty good. There's a way for us to actually calculate the confidence interval, but I'm not going to get into it because it gets pretty complicated. Due to the margin of error, an inference cannot be made regarding whether Mayor Ortega or his opponent will win the election. Well, if the confidence interval is between 44 and 52, is him winning an expected value? Let's say he wins if he gets 51%. So he wins with 51% and he loses with 49%. Hopefully that makes sense to everybody. Is 51% an expected value? Yes, it's inside the confidence interval. Is 49% an expected value? Yes, it's inside the confidence interval. So therefore, being how both him winning and losing are expected values, I really can't say who's going to win at this point. Just because I asked 48% of the people and they said they would vote for him does not mean there's a 48% chance that he's going to win. It means that there's an estimate that or it's approximately a 48% chance, but I can't definitively say there's a 48% chance. And finally, the last one, suppose two sets of test scores have the same mean but different standard deviations. Which statement best, and so the standard deviation of the second one is bigger than the standard deviation of the first. Well, if the standard deviation is bigger, that means, so let's say this is set 1 and set 2. If the standard deviation is bigger in the second one, it means that the curve is going to be spread out more. If the standard deviation is less, it means that everything's going to be tighter together. Remember, as sample size increases, standard deviation decreases. So if set 2 has a greater standard deviation, it's going to have more variability. So choice 2 would be the answer. Set 1 does not have a greater variability. If the standard deviation is smaller, then the variability is smaller. That's it. So I know a lot of different things we talked about. The main gist of all of this, to determine if something is expected or fair, we have to see if it falls inside the confidence interval. It's fair if the theoretical probability is inside the confidence interval. 0.5 for a coin. For the spinner problem, it was 1 over 6. If it does fall inside, then it's fair. If it doesn't, then it's not. If something falls inside, it's expected or usual. If it doesn't, then it's unexpected or unusual. We're going to move into the 4-point questions in the next lesson. Hope everybody has a great day.